All right, hello everyone. So today we're going to find the eigenvalues for the matrix, which has 3 rows and 3 columns. 1, 2, reading across the rows 1, 2, 0. Second row is minus 1, 2, 5, and third row is 0, 4, 1. All right, so we're basically going to follow a procedure here, which is it's like about 3 steps. Okay. Now, one thing I wanted to mention in terms of finding eigenvalues, this only works for n by n matrices, meaning the same rows and the same number of columns. A square matrix, you cannot have, it's not defined to find eigenvalues for something that's not a square matrix, okay? Just be aware of that. So the first thing you're gonna form is this matrix, which is lambda I n minus a. Lambda is just the number. It's the typical number, or in this case, it's actually a variable, sorry, that we use to find eigenvalues. This is that's just the Greek letter lambda, and then I sub n is the identity matrix. This identity matrix is the same size as what A is, so it's 3 by 3. So looking at what I have here, this is I sub n, and then that's lambda minus A. And I'm going to distribute that lambda in there because we're allowed to do that with algebra of matrices. And every entry gets multiplied by lambda. And now I'm going to subtract these 2 matrices, which involves me subtracting each entry. And if I were to do that, I would get lambda minus 1, 0 minus 2, which is minus 2, 0 minus 0, 0, 0 minus negative 1 is 1, lambda minus 2, 0 minus 5 is minus 5, 0 minus 0 is 0, 0 minus 4 is negative 4, and then lambda minus 1. Okay. So reading this across, it's lambda minus 1, minus 2, 0. Second row is 1, lambda minus 2, minus 5. Third row is 0, minus 4, lambda minus 1. Okay. The next thing I'm going to do is going to form this determinant of what I just found. This is what we call the characteristic equation. And essentially, we're going to take a determinant. And I'm not really going to go into how to find the determinant. I'll link a video in case you're wondering how to do this. But I'm going to expand about the first column here. And if I did that, I would have lambda minus 1 times lambda minus 2, lambda minus 1, minus 5 minus 4. And then a minus 1 times minus 2, 0, minus 4, lambda minus 1. Okay. And that would be my determinant, and all of that would be set equal to 0. Okay, so here's one thing that I recommend you do when you're doing these, when you're doing this part with the determinant. I suggest that you pay attention to the terms that you have, as in the sense that you don't want to distribute and multiply things out, because often if you do that, like distribute, multiply, add things together, you get a rather complicated polynomial to work with. Okay, like in this case, we would get like a cubic. And I mean, don't get me wrong, these are solvable a lot of the time, but you're giving yourself some more work depending on the expressions and the terms that you have. So let me get into that right now. So if I were to look at this expression that I have right here, well, this equation, excuse me, this would be lambda minus 1 and times lambda. If you did all the math, you would, inside this parentheses, you would get lambda squared minus 3 lambda minus 18. And then here you get plus 2 times lambda minus 1. Now the reason I'm going to stop here, and I'm not going to distribute the lambda minus 1 here or distribute the 2 in here, is because notice how you have a lambda minus 1 in common to both those terms. Okay, what does that mean? Well, that means you can factor that out, and all you would have left when you factored would be lambda squared minus 3 lambda minus 18 plus 2 equal to 0. And that would be your equation pretty much. One more step here. That lambda squared minus 3 lambda minus 18 plus 2 becomes this. And that's your equation. And then the next step is to solve for lambda here. And with this nice factored form, we can go ahead and set each term equal to 0 and solve. For this, I'd probably use the quadratic formula, so it'd be like 3 plus or minus the square root of 9 minus 4 times 1 times minus 16 all over 2. So 64 plus 9, I believe, is 73 over 2. So you get lambda equals 1, and then you get lambda equals 3 plus square root of 73 over 2, and then 3 minus the square root of 73 over 2. Okay, so those are your 3 eigenvalues. Yeah, it's really important. Once you get to this step right here, in my opinion, the more crucial step is when you're trying to calculate that determinant. And as I said, what people will do is they'll go ahead and like distribute the lambda in here, and yeah, which you can do obviously, but you get something rather complicated when you do that step. So I always tell people, be on the lookout for common terms that you could pull, common expressions that you could pull out of your terms, okay? So hope this helps, and thank you for your time.